times 2 pi. Okay. And now we plug in, right? Notice everything with 0 doesn't make sense, so we plug in 1. We get 2 pi times 1/3 minus 1/6. Now we just simplify, right? So if we want to simplify this, this is going to be multiplied by 3. Or sorry, by 2. That's just 1/6. So it'll be equal to 2 pi over 6, which is just pi over 3. And there is our volume using the shell method. Okay. So let's try another one. So example 2 says, find the volume of the solid as obtained by rotating about the y-axis the region bounded by the curve y equals the cube root of x, y equals 0, and x equals 1. So a lot of stuff happening again. Let's see what's going on. So if we just graph this portion, we're going to have 0, 0, 1, 1. So it's going to go this way. So y equals 0 is, again, is the x-axis, and x equals 1 is here. So this is our region we're going to be rotating about, again, the y-axis. Okay. So again, according to our shell method, it's going to be here. This is going to be our rectangle there. Okay. So the volume is going to be integral from 0 to 1 of 2 pi, and again, the radius from here for rotating to any point is going to be x times the function dx. Okay. So simplifying this a little bit. So putting this stuff together gives you x to the 2/3, and take integral of that. So adding 1, so adding 3 over 3 gives you 5/3. So this is 3 over 5 here. Evaluate 1 of 2 pi. Okay. And then just plug it in. So that's going to be 1, so it's 3 over 2. And 3 times 2 is 6, so 6 pi over 5 is our volume. Okay. Now, fun fact, you can actually do the disk method here as well. So, the cool thing about the shell method, it works universally, but, there could be ways where a disk or washer method could be used to make it simpler, right? Because, again, this could be a little complicated, especially for this extra r here, well, the r mean x here, when it comes to it. So this is another way you could have done. And then if you guys are interested in how you would do it using the disk method, well, according to our disk method, our portion will go from here to here, right? So this will be the volume of 0 to 1 of the actual value, 2x3 dx, or pi, actually, right? So if you want to write, if you go, just in case you guys forgot, this is equal to some a to b of pi r squared dx. And our radius, in this case, is exactly the radical, the third root of x. Well, squaring it gives you exactly what we integrated when it came to it. So fun little fact there. Yeah. All right, let's try the last one down here. So find the volume of the solid as obtained by rotating about the line x equals -1. So it's a little different now. The region bounded by y equals 4 minus 2x, and y equals 0, and x equals 0. All right, so let's again see what's happening here. So we were just graphing this. So if x equals 0, we get positive 4. X equals 1, we get 2. and x equals 2, we get 0. So here's our portion, and it's bounded between y equals 0, which is again the x-axis, and x equals 0, which is the y-axis. So here is our region we're going to be rotating. And we're rotating about the line y equals -1, which is right here. So we're rotating that way. Okay. So again, this is going to be our rectangle right here for our shell method. So according to our portion, it's going to be the integral from 0 now to 2 of 2 pi, and now this is where you got to be very careful of the radius. So remember, the radius is from what you're rotating to the actual curve. So notice it's big of a gap when it comes to it. So we're actually adding 1 then plus the function itself. So it's going to be plus 1 plus x, depending on where we're at itself. So that's going to be the radius times the height, which is the function, which is 4 minus 2x dx. So this same process is still used when we use a washer and disk method when it comes to finding the radius. Okay. All right, so simplifying this out a little bit more again, and just foiling this out should give you approximately this. Okay, and now we just integrate this, so we negative 2x to the third over 3 plus x squared plus 4x evaluated at 0 and 2 times 2 pi. Okay. And again, right, 0 doesn't matter, so we're going to just plug in 2. So 2 to the third power is 8 times 2 is going to be negative 16 over 3. 2 squared is just going to be 4, and then 4 times 2 is going to be 8. And this all things we times 2 pi. And again, this gives you approximately 13.3 pi. Once you add all this stuff, so right, this is going to be 12. Comment a number if you like. You want to put it in fraction, but that's perfectly fine if you want to do that. Okay. Now the cool thing is, like I said, in example 2, you can use the disk and you get the same answer. And this one down here, you can actually use the washer and still get the same thing as well. So there's multiple ways to do it, but again, the most common way is, like, for example, the first one, where it was almost impossible to solve for y, right? If we actually do it the washer method, good luck trying to solve for x, right? And that kind of process there. And that's why the shell method is actually pretty cool when it comes to it. Like worst case scenario when it comes to it. Okay. Right? And that is shell method.